We have a ball that is rolling along the table and it's launched horizontally off the table. So this is what we classify as a horizontal projectile. And a horizontal projectile has some important features to it. And the most important of them being is that once it's off the table, there is only one force acting on it, and that is the force of gravity downward. That means the net force in the x direction equals 0. And that means that ma equals 0 and the acceleration is 0. In other words, the velocity in the x direction is constant. So this v0 remains true until it hits the ground. It remains the case. So if that is true, using our formula, the average velocity is delta x over delta t, then delta x is equal to the average or constant velocity times the change in velocity, times the time that it's in the air. And this average velocity is v0. So the horizontal distance depends on two things. One, the initial velocity and the time. So let's look at the conditions. We know that when it is fired at v0, it travels a distance x0. So when it's v0, it's x0. So it's rolled off the same desk now with a new speed, 3v0. Well, and let me put this in here. This gives us a difference of x0. So when it's v0 delta t, it's x0. And now we have 3v0 delta t. The question then is, what happens to delta t? Well, what they're looking for in this question is to test a misconception that people have. And that is that if you change this velocity, somehow that'll affect the length of time. And what we know is it doesn't. It does not matter whether you drop this ball from this height or you fire it horizontally, they will hit at the same time. So what that means is that these two delta t's are equal to each other. So if that's the case, then it would travel a distance 3 times as far. If the delta t's are the same and the horizontal velocities are 3 times as large, the distance will be 3 times as large.